Hi guys, today we're going to talk about descriptive and inferential statistics. So descriptive statistics are used to describe and summarize data in a parsimonious manner. There are four different types of descriptive statistics: measures of central tendency, measures of variability, measures of relative position, and relationships. And we'll talk about these in a second here. You can also use graphs, such as a frequency polygon, to describe your data. So in this example, the vertical axis represents the frequency with which a score occurs, and the horizontal axis represents the scores themselves. So in this distribution or graph, you can see score 6 occurs a lot. Our majority of the participants scored 6, whereas there were very few participants who scored 3 and few participants who scored 9. So this is a data set that's normally distributed, and we'll talk about normal distribution a little bit later on. So the measures of central tendency are used to describe or represent the typical score attained by participants. So there are three different measures: mode, median, and mean. Mode is the most frequently occurring score, and it's typically used for nominal data. So nominal data is categorical data where the order of categories is arbitrary. So a good example is race or ethnicity has values 1 equal to white, 2 equal to Hispanic, 3 equal to American Indian, 4 equal to black, 5 equal to other. Now, if you think about 1, 2, 3, 4, 5 representing those categories, that's just arbitrary. I could have might as well assigned 1 equal to white as 4 equal to white, right? So I gave those numbers. So you use mode to describe the most frequently occurring data set, where you look at what's the frequency of your data set. Median is the score above and below which 50% of all scores lie. That is the midpoint. So for example, if you had, to start with simple, 5 participants who took a quiz, you would arrange their scores in ascending order, and then you would take the midpoint. So for 5 participants, what's the midpoint? Or what's the score where half the scores are below that and half the score is above that. So that would be the third data point, right? So similarly, if you have, say, 6 participants who took the quiz, you arrange them in ascending order, then you take the middle 2 data points or scores and take an average of that. So that'd be the median. Mean is basically the average of all scores. However, it's affected by outlying scores. So if you have 5 participants and there's one participant who scores out of 190, whereas the other participants score, say, around 60, so clearly your mean would be high because you have one participant who's an outlier. It's the most frequently used measure of central tendency. Again, the formula for mean is basically summing up all your data points divided by the number of observations you have. The measures of variability are used to measure the extent to which your scores are spread apart. Right? So what's the variability in your score? And there are, again, 3 measures: range, variance, and standard deviation. Range is the difference between the highest and the lowest score in a data set. Again, it's a very unstable measure of variability, but it gives you a rough and a quick estimate. It's unstable because, say, if you have one participant who scored high and one participant who scored very low, then the range only gives you the difference between their scores. Right? It doesn't represent your variability as well, because a lot of your participants are scoring around 60, say. Variance indicates the amount of spread among your scores. So if your variance is small, your scores are closer together. If it's large, the scores are more spread out. And the average squared deviation of all scores around the mean. That's what a variance is. And the formula for this is right here. Again, and there are statistical tools that you'll probably explore when you take a statistics course such as Stat 501 or 502, where you would explore like statistical software such as SPSS or SAS to learn more about how to do it, and you don't have to do it by hand. Another measure of variability is standard deviation, which is the square root of the variance. and it represents a relationship or shows the relationships to the properties of the normal curve, and it's easily interpreted. Now, again, this formula for standard deviation is the square root of variance. So what is a normal curve, right? So a normal curve is a bell-shaped curve reflecting the distribution of many variables that are interest to especially us in education. And a normal curve looks like this, okay? So you can see this middle point is the mean, and then here about 68% of the scores are within one standard deviation on either side of the mean, okay? 95% of the scores are in 1.96 standard deviation, and 99% of the scores are between minus 2.58 to plus 2.58 standard deviation, right? So if your data is normally distributed, this is what it'll look like. And I showed that again in the first or the second slide, looking at the frequency distribution that we had earlier. Again, the same thing, 50% of all scores fall above the mean, 50% fall below the mean. The mean, median, and mode have the same value. Most participants score near the mean, and the further a score is away from the mean, the fewer number of participants you have. As I said, 99% of the participants are between plus minus 2.58 standard deviation, 95% are between plus minus 1.96 standard deviation. However, you could have skewed distributions as well. So a positive skewed distribution is you have a lot of low scores and a very few high scores. A negative skewed distribution is where you have very few low scores and many high scores. Now, in a positively skewed distribution, the mode is the lowest, the median is in the middle, and the mean is the highest. Whereas in negative skewed distribution, the mean is the lowest, median is in the middle, and mode is the highest. Another measure are the measures of relative position. So these indicate where a score is in relation to all of the scores in the distribution. Now, it provides a clear estimate of relative positions, and you might use a measure of relative position if you want to compare students' performances across two or more different tests that are provided the scores are based on the same group. So for example, if you want to score a participant's quiz scores across two different quizzes, okay, for the same participant. Now one quiz, say, uses a scale of 30, so highest one could achieve is 30, and say the other quiz has highest score of 50, right? So how do you compare the means? Because those means, where in one you can only score 30 and the other you could score 50, those means cannot be compared directly. That's where measures of relative position come into play. So these are standard scores. These are derived based on how far a raw score is from a reference point in terms of standard deviation units. So there are three types: z-score, t-score, and stanines. So z-score, the deviation of a score from the mean in standard deviation units. Z-scores have mean equal to 0, standard deviation is 1. Positive if the score is above the mean, and negative if the score is below the mean. And here's the formula to how to calculate a z-score. So you take a participant scores minus the mean divided by the standard deviation. T-score might be used if you don't like negative scores, right? So it's basically a transformation of z-scores to avoid negative scores, where the formula is t equal to 10 times z-score plus 50, right? So the mean in this case is 50, the standard deviation is 10, and there are really no negative scores in this because you've converted the z-scores. Stanine is transformation of a z-score again, where the stanine score is 2 times z-score plus 5 and rounded to the nearest whole number. Okay, so there are 9 groups with 1 the lowest and 9 being the highest. Okay. We have talked about relationships in terms of correlation coefficients when we talked about correlational research. The purpose is to provide an indication of relationship between two variables, the characteristics of correlation coefficient, the strength or the magnitude of the relationship. It ranges from 0 to 1, and the direction, whether it's a positive relationship or a negative relationship. And there are two types of correlation coefficients that are used. Spearman's rho, which is used for rank data. So rank data, it's a set of labels applied to groups composed of individuals with similar characteristics, right? Where labels indicate more or less of a quality and can be rank ordered, and rank ordered in a meaningful way. For example, liking of mathematics, low, medium, high, right? So that would be rank data. Pearson's R is used for interval data. So interval data is where numerical values that are assigned to participants or individuals, where numbers can be characterized by mathematical functions of equal to, less than, greater than, not equal to, plus, and minus. So intervals are assumed to be equal across the range of measures. For example, Fahrenheit scale of temperature, right? You could have greater than, less than, not equal to mathematical functions with that, and they're assumed to have equal range across. Um, the difference between 10 Fahrenheit and 20 Fahrenheit is the same as difference between 30 Fahrenheit and 40 Fahrenheit. Okay, so that's interval data. Interpretation, looking at a correlation coefficient. Okay, so correlation does not mean causation. That only means that a relationship exists between two variables. It does not mean that one variable causes the other variable or changes in the other variable. Again, recall that in order to establish causal relationships, we have to do experimental research. Okay, correlational research is only used to establish relationships. Again, here's a formula to calculate Pearson's R, or correlation coefficient, where x is one variable and y is the other variable. Again, statistical tools like SPSS allow you to do this, calculate this without having to hand calculate. And again, I said you'll explore that in other statistics classes that you might take.